Hello, everyone. So last time we were still doing counting problems and we did pigeonhole principle. Now today we want to start permutations and combinations. Permutations and combinations. Let's look at the definition of a permutation first. So definition, a permutation of a set is an ordered arrangement of elements of that set. Okay, ordered. So the important word is ordered arrangement. So the order is important and relevant when we talk about a permutation. So for example, permutation of, let's say, that says, for example, 1, 3, 8. So let me say some permutations. So let me list all of them, just 6 of them, all permutations. So 1, 3, 8, 1, 8, 3. See, 1, 3, 8 is a set. When we talk about a set, of course, the order is not important. You can write the elements of a set in any order and the set's still the same. But if you want to talk about permutation, then the order is important. So 1, 3, 8 is, when you talk about permutation, is not same as 1, 8, 3 because the order is different. Or 3, 8, 1, 3, 1, 8, 8, 1, 3, and 8, 3, 1. So see, there are 6 of them. So 6 permutations in total. So this set has 3 elements and has 6 permutations. So there are 6 ways to order the elements of this set. Now, let's say if we have a set with R elements, how many permutations do you think we have in total? So note the total number of permutations of a set with R elements is how much? So let's say we have a set with R elements. So let's say, for example, A equals A1, A2 to AR. So in how many ways can I order them? So if I consider R spots, so the first square for the first spot, which means the first element that I want to list, and then the second element that I want to list, and so on, until the rth element. So for the first spot, how many options do I have? Because I have R elements to choose. So R options. This is the number of options for the first spot. And then for the second spot, I'm going to be left with R minus 1 options, right? Because one element has been already chosen for the first spot. And of course, I can't choose that one anymore, right? It's already been chosen. So I am left with R minus 1. The number of options for the second spot. And so the next spot are minus 2 options, and so on. And the rth option, I'm going to be left with only one option for the rth position. Number of options for rth position. All r minus 1 elements were chosen before. Okay, so in total, how many options do we have? So in total, using product rule, right? In total, we have r times r minus 1 until 1, which is r factorial options. To arrange r elements in an ordered way. i.e. r factorial permutations, right? Product rule says that if you want to perform, okay, let me see, my screen is freezed. I'm going to share again. Product rule says that if you want to perform few tasks, let's say first task in one option, second task in two options, and so on, then in total you will have n1 times n2 times n3 times so on options to perform all these tasks together. Okay, so here we have r options for the first one, r minus 1 option for the second one, all the way to 1 options for the last one. In total, we have r times r minus 1 times all the way times 1. And this is the definition of r factorial, right? R factorial means 1 times 2 times all the way to times r. So r factorial permutations for a set with r elements. So for example, number of permutations of, let's say this set, for example, 1, 8, 9, 10, is how many? So this is a set with 4 elements. So according to what we just derived, the number of permutations is 4 factorial, which is 1 times 2 times 3 times 4, and that is 24. You can also verify this by listing all permutations, like what we did for 3 elements here, and there were 6 of them. Here you can also list all the 24 permutations and verify the fact that this set has 24 permutations in total. Okay, so another note. You say by R permutation, this is a term that is used in your book. By R permutation, we mean a permutation of a set with R elements. With R elements. So this is the term that's used in your book. R permutation means a permutation of a set with R elements. Okay, next, we want to find the formula. Next, consider the case where we choose R elements from a set with N elements. So number of R permutations chosen from a set with N elements is denoted by PNR. Okay, so we have a set with N elements and we want to choose R of them. And we want to count the number of permutations of these R elements when they're chosen from N elements. Previously, see, we were not choosing. So for example, we had a set with 4 elements and we wanted to permute all elements inside the set. Now, let's say if we have a set with 4 elements, I want to permute 3 objects chosen from these 4 elements. So this is the difference. So previously we were not choosing any elements, we were just changing the order, right? But we were listing all the elements of the set. But here we have a set with N elements and we want to choose R of them first. And then of course, yes, we have to order those R elements as well. So we want to count the total number of R permutations, which means permutations of a set with R elements chosen from a set with N elements. Of course, N has to be bigger than or equal to R, right? Because you want to choose R elements out of N elements. So that means, of course, R has to be less than or equal to N. Say with R less than or equal to N. So let's say, so we want to know the formula for P and R. So let's say if A is A1 to AN, and I want to choose R elements here. In how many ways can I do that? So again, see, I have, remember the order is important for me. When we talk about permutations, means order is important. So it's important which one is the first element, which one is the second element, and so on. So I put a square for the first element or first position, and then second element, rth element. Now, for the first element, how many options do I have to choose from? Because A has N elements in total, right? So I have N options for the first spot. Number of options. And then again for the second spot, because one element has been already chosen, right? So how many elements I'm going to be left with? So for the second spot, I'm going to be left with n minus 1 options. Number of options for the second spot. Right? One element was chosen for the first spot, so n minus 1 elements left for the second spot. And so on. For the rth position, how many elements? So we can see the pattern, right? So first element n, second n minus 1, third n minus 2. Do you see the pattern? See, for the first we have n, for the second we have n minus 1, for the third we have n minus 2, for the fourth we have n minus 3, right? So if we continue this way, for the rth position, well, some people say n minus r, but obviously it's not n minus r, because if it was n minus r for the second spot, I should have had n minus 2, right? But it's not n minus 2, it's n minus 1. For 3 is n minus 2, not n minus 3, right? So for 2, in other words, it's n minus 2 plus 1, which is n minus 1. For 3 is n minus 3 plus 1, which is n minus 2. For 4 is n minus 4 plus 1, which is n minus 3, and so on. For the rth position is n minus r plus 1. Rth position, n minus r plus 1. So n minus r plus 1. Number of options for the rth spot. Okay, so the total number of permutations of R objects chosen from N objects. So it's the sentence, it's a long sentence. That's why we just abbreviated by PNR. PNR means number of R permutations chosen from N, a set with N elements. So thus, again, by product rule, right? Product rule, PNR, i.e. number of permutations of R elements chosen from N elements is given by P and R equals, so I have to just multiply them, right? So for the first task, we have N options, second task, N minus 1 options, and so on. So for overall, I have to just multiply these elements. So N times N minus 1 all the way to N minus R plus 1. This expression can be written as P and R equals N times N minus 1, N minus R plus 1, N minus R, N minus R minus 1, all the way to 2 times 1 divided by N minus R, N minus R minus 1, all the way to 2 times 1, right? Do you agree? See, look at these expressions. The only thing that I did here is that I multiplied and divided by this expression, N minus R times N minus R minus 1 times all the way to times 2 times 1, divided and multiplied by this expression. Now, the numerator would be what? So 1 times 2 times all the way to N. So that's equal to N factorial, right? And denominator 1 times 2 all the way to n minus r is n minus r factorial. Numerator is n factorial, denominator is n minus r factorial. So that's it. So we showed PNR equals n factorial over n minus r factorial. Okay, let's look at an example. So suppose that in a class with 10 students, we want to choose a committee of 3 where a committee of 3 where the first person will be the chair, second person will be the assistant, third person will be the secretary. Find the total number of ways to choose this committee. So let's see whether we can use the concept of permutations to solve this problem. So permutations P and R. What does that mean, or when can we use it? If we have a set with n elements and we want to choose R of them. And don't forget one more important thing. We have a set with n elements, we want to choose R of them. And the order must be important and relevant, because when we talk about permutations, order is always relevant and important. So if you have a question where the order is not relevant, then you should not use permutation. You should use combinations, which we will see in a few minutes. For permutations, order must be important and relevant. So is order important here? We have a set with 10 students. We want to choose 3 of them as a committee. Now the order is important. Why? Because the first person will be chair, second person will be assistant, third person will be secretary. So their title and their position will be different, right? So for example, let's say I want to choose student 1, 2, 3. If all the students are labeled as student 1, 2, 3, all the way to 10, let's say one way is that I will choose, let's say, student 1, 2, and 3 for my committee. But if I choose student 1 and student 2 and student 3, right? So see student 1, student 2, student 3. This is different than when I choose student, for example, 3, 2, 1. Or 3, 1, 2. See, in all these cases, still student 1 and 2 and 3 are chosen, but their order is different. And if I change the order, their positions will be different, because see, these are really different possibilities, because in the first possibility, student number 1 will be chair, but in the second possibility, student number 1 will be secretary. In the case number 3 or possibility number 3, student 1 will be assistant. So these are really different. The order is important here, right? All these possibilities, the same students have been chosen, but their order are different, which leads to different cases. Of course, it's important for student 1, whether, of course, it's important for him or her, whether he or she will be chosen as an element, as a member of committee. But even assuming that he or she has been chosen as a member of committee, still is important for him or her to be whether a chair or secretary or assistant, because then he or she will have different role in that committee. Okay, so you can say that solution, we want to choose 3 elements, 3 members out of 10 students, and the order is relevant since the position title of the first, second, and third person will be different. So the total number of ways to do so is P 10(3), which is equal to 10 factorial over 10 minus 3 factorial, right? And this is 10 factorial over 7 factorial. And that's going to be, so 10 factorial, I can write it as 7 factorial times 8 times 9 times 10 divided by 7 factorial, right? 10 factorial means 1 times 2 times all the way to 7 times 8 times 9 times 10. So 1 times up to 7, I can write as 7 factorial, and then times 8 times 9 times 10. And then this cancels with this. Seven factorial cancels with 7 factorial. And then I'm left with 8 times 9 times 10, which is 720. Okay, so there's 720 ways to choose a committee with 3 people and with having a different position titles for the members. First person being chair, second person being assistant, third person being secretary. Okay, so this is the concept of permutations. Now let's look at the concept of combinations. So this time again, suppose that we want to choose are elements from a set with n elements, and this time the order, and suppose that the order is irrelevant. So similar situation to permutations P and R. The only difference is that for P and R permutations, the order was relevant. Here, the order is irrelevant. How do we know whether the order is relevant or irrelevant? Well, we have to read the question carefully. So for example, in previous example, we were saying that we want to choose a committee of 3, and the first person will be chair, second person assistant, third person is secretary. But let's say if I don't say this, if I say that I want to choose a committee of 3 and all 3 people will have exactly the same role, or in that case, the order will be irrelevant, right? Because in that case, for example, student 1, 2, 3 and student 2, 3, 1 will be same, because no matter whether student 1 is chosen as the first person or as the third person or as the second person, he or she will have the same role anyways, right? So the order will be irrelevant, right? So you have to read the question. If the question says first person title, second person title, third person title will be different, then the order will be relevant. If all the titles are the same, then the order will be irrelevant. Okay, so suppose that we want to choose R elements from a set with elements, and suppose that the order is irrelevant. The total number of ways to choose R elements that is the total number of ways to do so is denoted by CNR, or another notation, N choose R. So read N choose R. Okay, so this is also called combination, of this C basically is denoting combinations. R elements chosen from N elements. And C and R, or N choose R, we have two notations this time. Some books use C and R, some books use N choose R. And some books use both. I think your book uses both notations. So now what will be the formula for C and R? And the screen freezed again. I'm trying to connect the screen. Seems there's some problems. Okay, so we know the formula for P and R, right? So we know P and R equals n factorial over n minus r factorial. Now, what is the connection between, so if I can find the connection between P and R and C and R, then I'm done. Because once I find the connection, I already have a formula for P and R. I can find a formula for C and R then. So P and R means R permutation. R permutation means a permutation of a set with R elements chosen from a set with n elements. So suppose that R elements, let's say A1, A2 to AR, are chosen okay, so R elements A1 to AR are chosen. Now, when we talk about the PNR, for example, A1, A2 to AR, or A1, A3, A2 to AR, or I don't know, AR, A1, A2 to AR minus 1, or, you know, AR minus 1 to A2, A1. So all these will be different when we talk about permutations. But when we talk about combinations, all these arrangements are considered as only one arrangement, because then the order, I have to ignore the order for combinations. Okay, so how many such arrangements do I have? So in the context of combinations, all these are factorial permutations are considered as a single arrangement. So R factorial permutations we have for A1 to AR, R factorial different ways that we can change the order and get different arrangements in the context of permutations. But all of them, because same in all these arrangements, because same elements are chosen, A1 to AR. So all of them in the context of combinations are counted as one, as a single arrangement. Because in combinations, we ignore that order. So then what is the connection then? Every R factorial elements in permutation are considered or counted as one element. So for example, if you have, let's say 10 people and you want to divide them into groups of 2 people, how many groups would you have in total? If you have 10 people, you want to divide into groups of 2, then you would have 10 divided by 2, which is 5 groups, right? So same thing here, we have P and R elements or objects in total, and we want to divide them into groups of, and each group has R factorial elements in it. So in total, how many such groups do we have? Same thing, same idea that I just told you about 10 students, groups of 2. So we just need to divide P and R by R factorial, because we have P and R elements in total, and inside each group, we have R factorial objects. So how many groups do I have? Well, P and R divided by number of elements inside each group, right? So we want to divide, if we say this way, we want to divide P and R objects into groups of R factorial elements. The total number of such groups i.e. C and R is given by C and R equals P and R divided by R factorial. So what's that going to be? P and R is n factorial over n minus R factorial, then divided by R factorial. And the answer is n factorial over R factorial times n minus R factorial. So we showed that C and R equals n choose R equals n factorial over R factorial times n minus R factorial. Okay, so this is a formula for C and R or the combinations. So it's similar formula for P and R. The only difference is that it's divided by R factorial. So instead of n factorial over n minus R factorial, here we have n factorial over R factorial times n minus R factorial. So let's look at an example. So again, suppose that we have a class of 10 students, and we want to choose again a committee of 3, and assume that all members of the committee will have the same role. Find the total number of ways to choose such committee. So solution, again, we want to choose 3 members, 3 members out of 10 members, 10 members, and all members, and all members have the same role. So the order is irrelevant, right? Because they have same role, it doesn't matter that, for example, if a specific student wants to be chosen, it's not important for him or her whether he or she is chosen as the first member or as the second member of the committee, because he or she will have the same role anyways. So the order is irrelevant. Thus, the total number of ways to choose such committee is C10, 3, which is 10 choose 3. And so C10, 3 equals 10 choose 3 equals 10 factorial over 3 factorial times 7 factorial. And that's 8 times 9 times 10 divided by 6. And this is, so I can simplify this as 4 times 3 times 10, 120. So our total number of ways this time is less. In fact, it's 1/6 as of the previous case where the order was important. And this is natural because every 6 elements in the previous example, every 6 of them is counted as 1 now, right? So previously we said, if you choose student 1, 2, 3, student, yeah. Here we said student 1, 2, 3, and student 3, 2, 1, 3, 1, 2. All these will be different. Although in all of them, student 1 and 2 and 3 are chosen, but because the order is different, the choice is also different. But here, because they have all the same role, all these choices are counted as one choice. So every 6 of them is counted as 1. So then connection, as we said before, is that the combinations, because we have 3 elements, the combination is the same as permutations divided by 3 factorial, which is the number of permutations for 3 elements. So that's why the final answer for new example is same as the final answer of this example when we divide it by 6. Okay, so that's the idea behind it. But in the exam, you don't have to explain all these things. If you just write it like I said, because we already use this idea to to prove a formula for combinations, right? So in the exam, of course, you're allowed to use the final results unless the question asks you to prove a formula for combinations. Otherwise, if you want to use the formula for combinations to solve a specific example or specific question, you don't have to mention the reasoning that we use to derive the formula for combinations. You can just simply use it. Okay, so in the exam, you should just write what I wrote here, that because the order is irrelevant, we have to use combinations, and the formula for combination, we already know it. You can just use it. You don't have to prove it. And just use the formula and get the final answer. That's it. Okay, so this is the concept of combinations.